Today, we're going to be talking about how size and speed are intertwined relative to each other and proportional to each other based on the observer's perspective. Now, in science type stuff, there's a theory of this, theory of that. I don't know them all, okay? But I'm pretty sure I haven't heard about this before. This is something I've been thinking about for a very long time. Now think about this. All right, let's. I'm just going to give you a bunch of examples because I don't know how else to explain it. Let's go big first. We'll go small second. Most people are human-sized people, and we live on an Earth-sized planet, and that's all we've ever known. And as such, we can see things that are crazy big because we have telescopes, and we can see things that are crazy small because we have microscopes. And that's all fine, and those things are moving, both of those things. They're always in motion, lots of stuff's in motion. But the speed that it's moving at, we can only perceive it at what we think it's moving at because we are what we are. Let's think about this. What's a little bit bigger than us? We're just going to gradually go up the ladder here. The sun's bigger than we are, and it has its own little solar system. Alright?
I'm pretty sure that the sun is bigger.
So if you were the sun, and you're watching these planets rotate around you in your gravitational pull, you think that would the Earth would 365 days make a year? Yeah, I mean, I suppose so. But the sun doesn't see it like that. That Earth, that's going fast. That thing's going like around you like crazy. You got Jupiter over there. In our perspective, what does that take, like 12 years to get around the sun? You know how much stuff can happen in 12 years? 12 freaking years? The sun isn't seeing it like that. The Jupiter's going around like a freaking tetherball, okay? You ever been in 8th grade, like in recess, and you're outside at recess and you get hit in the face with a tetherball? Tetherball Jupiter is going fast. That thing's going same as the Earth, probably faster. Because something larger like the sun would perceive it as whipping around a very lot faster than us down on Earth. Our human-sized people are watching it happen. Let's go a little bit bigger now! What's bigger than a solar system? A galaxy that's got lots of those solar systems in them? Like a million, billion, trillion of them? Okay, that thing's spinning around too. Because lots of stuff in nature spins around. So the galaxy's rotating too. And I remember being in school when I was little, and they were like, the entire time that mankind has been alive and on this planet and living, the galaxy hasn't even gone around. Not even once, not even half of once. And I thought to myself when I was little, wow, a galaxy's slow. It's ridiculously inefficiently slow. Alright, but that's not the truth. That thing's spinning around like crazy fast. Way faster than these planets are spinning around, right? And you got like dinosaurs. What was that, 65 million years ago? 65 million years? The dinosaurs over there, they were like on the other side of the galaxy because it's only gone around halfway since then. So they were like on the other side. Not even a full rotation yet. No, that doesn't even make any sense. That galaxy, it only makes sense to us. That galaxy That thing's spinning around like you're flushing a toilet. Alright? That thing's a black hole in the center of a galaxy, right? What do you think a toilet is? It's the same deal. Black hole right in the middle. Freaking everything else is swirling around. Look, I drew a diagram so we can all be on the same page about what I'm talking about. Alright? Look at my diagram. Alright? That's a galaxy right there. Same thing. Alright? When's the last time you flushed a toilet and it took 65 million years to go around halfway? Never freaking happened. It's just our perspective on how slow it's moving. What's bigger than a galaxy? The universe. It's got lots of galaxies in it. Alright, and the galaxies, they're all, we say they're drifting further away because of the Big Bang and whatever, and some of them are colliding with other ones. We have our closest neighbor galaxy, the Andromeda Galaxy. It's said to be on a crash course collision course with our galaxy, the Milky Way. And that's going to happen in like however many billions of years or millions of billions of years. It's so far in the future that we don't even care. The Earth won't even be here anymore. So it's really like a we don't even care kind of thing. Way too far in the future. You really think that's the way that's happening? No. Them galaxies that are flying around and floating around in the universe, those things are like boo, 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 boo. They're like a freaking Star Wars laser battle scene is what's going on. So all these little galaxies, they're all like playing Star Wars over here. And we're like, nah, the Andromeda Galaxy is gonna be like a freaking trillion, billion, quadzillion years in the future. That's just our perspective. Alright, Big Bang. They're all drifting further away. Drifting? No, nothing drifts. The Big Bang was an explosion. An explosion! Alright? Now, you ever seen an explosion go slow like you would use words like drifting? No. Explosions happen fast. They're like, boom! You know? Whatever caused that, or whatever that actually is in our little narrow-minded perspective, it's actually still occurring. Still occurring. It's still exploding. It's still in the process of exploding, because now we're up at that level of size. Those things aren't drifting. Those things are being propelled with an explosion force away from each other. And we're like, yeah, well, they get a little further, every year or two, But no, that's not the way that happens. Those things are freaking in the process of exploding away from each other, but we can't perceive it like that. Now, we can go small, too. Let's say what's smaller than a human-sized person. Let's go a little small. Ants are pretty small. You ever see an ant like scurrying across the sidewalk or your driveway? Those little legs, they're like moving along like crazy. You never think to yourself, well, if I was ant-sized, there's no way I could keep up with that thing. I couldn't race that ant if I was an ant-sized person, because you don't stand a chance. In comparison, we did dinosaurs, okay? Dinosaurs are big, okay? Very opposite of ants. Those things aren't like that. Dinosaurs come walking around freaking Brontosaurus and whatever. They're all like slow motion. You know why? Because you're a lot smaller and they're a lot bigger and there's a whole different perspective going on. Dinosaurs, they come up and they're like like that, okay? Now what if you Honey, I Shrunk the Kids yourself and you were like human-sized to an ant that was brontosaurus-sized to you. All right, and so you're looking at a brontosaurus ant coming right at you. Do you think that thing's really scurrying? Like, no, it's gonna brontosaurus at you with the slow motion, with the totally different perspective. And it's even smaller than that. We got atoms. Have you ever heard of atoms? Because we have atoms too, you know. Atoms, so like a regular human-sized person like me or you are looking down in the microscope at an atom. It's got a nucleus, and the electrons are going around the outside. And they're like spinning around, they're like crazy fast. And we look down at that, we're like, I don't even know what's going on down there, because that shit's happening so fast. Well, that's not like that. What if nucleus was like a planet, and you're on it, like even a proton of that nucleus. Let's say you're on a planet-sized proton. You shrunk yourself down that small. So let's say you're on planet Proton down there, and you're like a little microscopic person on planet Proton, and you're watching these electrons all floating around. Might as well be Jupiter, right? What was that Jupiter business? 12 years to make a rotation? So you're watching the electrons. I'll see you again in 12 years, electron. Yeah, it's not really happening like that. That's just your perspective, because size and speed are relative and proportional to each other based on your perspective of the observer. And whatever else, too. You got like, what's kind of small? You got hummingbirds with a fast motion. With the wings, they have wings. You ever see a hummingbird? You ever watch it like eat out of like a hummingbird feeder? You can't even see the wings because they're all like that. You can't even see them. They basically just look like a bird that's like floating in the air. Hummingbirds float in the air, you know, but not really. We just can't see the wings. You ever see a video of it? It's pretty much no wings. They're just floating. But what if you're like a microscopic bug or like a parasite, and you're on the hummingbird's like nose or something? You're not going to notice any of that motion or speed at all. Okay? One day you're on that beak, you're microscopic, and you go, I'm gonna take a look back at these wings that attach to this creature that I'm on, and then those wings, you look back at them, you're not seeing them do the thing. No, they're like slow motion brontosaurus, like pterodactyl, like slow motion, like. You know, like that. What if you were a universe-sized person? All right, and you're looking down at all these little galaxies. They might as well be dust to you. You can't even tell what's going on. All right, but all those galaxies got billions of little solar systems in them, and they're all rotating too, just like the atoms. Same deal. You wouldn't even be able to tell the difference. You think a human lifespan, you'd be able to like see it happen? Not even close. Human lifespans would be like boop 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 boop. They'd come and gone. You wouldn't even know what's happening. Probably all of human existence would happen without you even knowing it's happened. That's how quick it would be if you were on that type of scale. Does that even make any sense? This sort of perspective is it's a big deal. I think we should be talking about it a lot more often, and I'm not even sure why we're not. If this is something that's already been written or theorized about, I don't know it, but I've been thinking about this for a long time, and I'm pretty sure that I'm not wrong. I'm pretty sure that I'm not wrong. Think about it a little bit harder. If you got anything to add to it, please let me know, comment or whatever, because I would love some more examples. I'm sure I have a billion more. This is all I have off the top of my head. But this is a real thing that is going to need attention, I believe. And I think it's a lot more important than most things that we think about on a daily basis. So, important shit. Size and speed are relative and proportional to each other based on the size of the observer's perspective. Are we all on the same page about that? I would hope so.